Hello everyone, this is me Simran Anand, and I'm currently a final year engineering student pursuing computer science engineering. And here I am to demonstrate a short video explaining a particular topic of artificial intelligence. Artificial intelligence is my favorite subject, and I believe it has a lot of potential in these days. It has become a booming technology and it is widely used and leveraged in the industry today. So I'm just going to go back to what I'm explaining. Since I have written many blogs on artificial intelligence, this is one of my blog which I've written to start off with. The topic I'm going to explain today is about sentiment analysis via natural language processing and machine learning. This is a blog which I've written, but before I would start, I would like to give you a brief introduction about artificial intelligence. So, what exactly is AI? If we keep hearing about the cutting edge technologies today, so artificial intelligence is the science of making machines to think like human beings. We know that human beings' brain is structured in such a way it has neural net is like a neural network which has many deep layers, and all the neurons are connected and interlinked to each other, and they send in messages, and the signals get transferred to each other. And the same way, the science of helping the machine or the model, which is the machine learning model, to think and act like a human being, giving it the cognitive abilities, is like the human being, is called as artificial intelligence. So there are various domains of artificial intelligence. To I would just explain you with the help of a PowerPoint presentation which I have. I found this presentation online, and to start off with the domains of artificial intelligence. So we know that artificial intelligence is training a machine to think like human beings. There have been many domains of artificial intelligence these days, like data. Data analytics, in fact, is leveraged to help artificial intelligence grow. And there are domains like computer vision, which deals with images. Image processing falls under the category of computer vision, then followed by natural language processing, which is my favorite domain I have worked on. Natural language processing deals with textual data. So it is basically sentiment analysis and textual classification or recommendation engines. These all are the domains which fall under natural language processing. It is basically analyzing the sentiments and the opinions of people behind the text. That is called a sentiment analysis. So to move forward, this is clearly showing the difference between data, natural language processing, and computer vision. As we can see that, put in simple words, computer vision deals with images, natural language processing or NLP deals with textual data, which can be in the form of video data as well, sound data, speech data. This is nothing but data. Data, in fact, is analyzed using prescriptive analytics, descriptive analytics, diagnostic analytics, and predictive analytics. It is analyzed to using the different technologies like NLP and CD, that is nothing but computer vision or OpenCV, and these are done with the help of different deep learning techniques or machine learning models as well. So, what is the main difference between deep learning and machine learning? Is that deep learning is a subset of machine learning. Machine learning basically deals with the mathematical aspects of artificial intelligence. There are different kinds of algorithms which the machines are leveraging. For example, you might hear about prediction, stock market prediction. So that linear regression, logistic regression, support vector machine. These are few of the examples and of algorithms in machine learning. Machine learning is also of three types: supervised, unsupervised, and reinforcement learning. Supervised learning is when the human being is teaching the machine by giving labeled data set. It is giving the data, a teacher is teaching a student, is an example of a supervised machine learning. Whereas unsupervised machine learning is when the teacher is giving the student, here in my case, it is a human being which is training the machine on unlabeled data. The teacher is testing the student on something which she has not taught before, and then seeing if the student is able to recollect the information which has been taught before. So that is on unlabeled data. That is an example of unsupervised learning. And reinforcement learning is the most advanced kind of machine learning technique, and that is where incentive is given or a punishment is given depending on how the work is done by the student or the machine. So the machine is giving the right output, that is where the incentive or a credit is given, an encouragement is given. But when the machine does not give a correct output on classification or regression, does not predict the correct output, that is where the punishment penalty is given. That is an example of reinforcement learning, and it is especially used in the gaming industry today. So I just give you in a short nutshell about the machine learning techniques. And coming to the deep learning aspect, deep learning is all about neural networks, the biology of the brain. There are various deep learning models which are trained on high training GPUs and TPUs on machines. They are basically, deep learning is used when the data is humongous. When we have a lot of data, that is where deep learning comes into the picture. And also, there are various techniques in order to see that how the machine learning models can be leveraged with deep learning as well. NLP and CV also come as a part. These all are a subset of artificial intelligence. So natural, as you can see here, natural language understanding, question and answering. You've heard about chatbots or robots that also come under natural language processing as they work on textual data. So for learning textual data, I have a beautiful blog which I've written. I would showcase it to you later. So here, task domains of AI, as you can see here, perception, vision, speech. There are various automatic speech recognition systems like ASRs, even the Google Siri voice assistant and Amazon's Alexa. They all work on the principle of natural language understanding as they work on speech data, text to speech conversion, and vice versa. There are formal tasks in games. A lot of mathematics is involved in artificial intelligence, and as well as stock market analysis, financial analysis, medical, even in the medical field, artificial intelligence is being leveraged. So this is a small brief I have given about artificial intelligence with the help of this PPT. And coming to the programming language, Python and R are the two programming language which are most suitable for data science as well as artificial intelligence domains. Python is used, especially I work on Colab, Google Colab, Jupyter Notebook, and Anaconda. So there are various IDs and platforms on which artificial intelligence tasks can be implemented, and a lot of researchers have been done on the same field. So there are various IDs, and coming to the R part, that is mainly for the data visualization. We know the data can be visualized in the form of graphs, in the form of images graphically. There are different word clouds, different form of graphs like bar graphs, pie chart. All these can be the data can be visualized in such forms using R or Python in different libraries of Python like Matplotlib, Seaborn, if you've heard of. So not to worry, I will just take you through my blog first. So this is a small blog which I've written on sentiment analysis via NLP and machine learning. I've given you a gist about what is sentiment analysis, how exactly it is used in the finance domain, in the understanding of the business domain. Even businesses use sentiment analysis to understand the feedback of their customers. They want to know what is the sentiment or what is the opinion behind the text which the customer is given. Even we are sometimes curious whenever a friend messages us. We sometimes don't understand the context of that message. So we Google it up and all. But this understanding, there are different machines which have been trained on understanding the underlying sentiment, which is nothing but the opinion behind the text. That is the sentiment analysis. So when it comes to the different techniques of NLP, there are tokenization, stemming, lemmatization, syntax, semantics, and phonetics. Tokenization, you know that a word can be broken or simplified into different words. So small chunks of word. So tokens, different tokens of words. So tokenization is the technique of breaking sentences into individual tokens or characters to identify named characters like entities, be it noun, pronoun, article, etc. in a sentence. So, for example, if I give you a sentence like AI is a very interesting subject. So we know that what is the noun here, pronoun here, article. So AI is an interesting subject. Interesting is the adjective here, whereas AI is the noun here. Noun as in it is the name of a subject, and subject, noun, these all are the different entities in different tokens or a part of the sentence. That is tokenization. Coming to the stemming. Stemming is the process of shortening of a term or a word to its root form or a base form. But this, it does not produce words which are always meaningful. Semantically, semantic is the meaning. What exactly is semantics? Semantic is meaning, and syntax is the grammatical structure of a sentence or a word. That is syntax. Phonetics is the refer to the verbal pronunciation of a noun or a term. That is phonetics. So coming to the semantical aspect, I would say that lemmatization rules over stemming, because lemmatization is also shortening of a word or stemming of a word to its base form. For example, walking. Walking can be stemmed or shortened to walk. So walk over here is the root word. So lemmatization, the difference between stemming and lemmatization is that lemmatization sees to it that even though the word is shortened, it retains the base word which is meaningful. Whereas stemming sometimes does not return the meaningful word. For example, if I say, walking, it might not return walk always. Let me give you another example. For example, danced. Danced is the past form of dance. It will just return as dancing or dance, but it will not return something which is meaningfully correct. That is what is stemming. Then syntax is the grammar associated with the language, as I've told you. Semantics, the meaning, the logic of the language. Now, coming to the fundamental steps or the cycle process involved in NLP, it is first always any artificial intelligence project starts with the data. So data collection is the most important aspect, and data can be collected in any format. Believe me, it can be collected in the form of a CSV or an Excel file, JSON data, any kind of a data. So all the data which is collected, I will also implement one of the Google Colab project which I have done, and I would show you how the data is being collected. There is a library in Python called Pandas library. So that is what makes pandas easier for us to manipulate on data sets. So coming to the next step, which is text pre-processing. All this which I've told you, tokenization, levitation, stemming, imputations, these all come under text pre-processing. Then followed by sentiment analysis after data exploration, training, evaluation, and deployment. Now, we understood what is training. Training is nothing but we are feeding the data to the machine. After cleaning the data, removing all the outliers or all the anomalies from it, and we have been training the data, they're training the machine with the data. After training the model captures some understanding. Now, how to understand if the model has actually, the machine learning models trained properly, or there is a lot of noise in the data, how to improve the accuracy, that is where the evaluation aspect comes into picture. After the evaluation is done correctly, we deploy the model. Now, what is deploy? Deploy is to put the machine learning model we have trained into production. Production, when I say, there are different platforms like Streamlit or Flask. There are different even cloud technologies like AWS, Azure. These are different the deployment engines which are helping the machine learning models to come into production. I worked on Flask, so I know how models are deployed. There's a TensorFlow library which can be exported into TensorFlow Lite, and then we can deploy it as a mobile application as well. I have also deployed a sentiment analysis project which I have done as a mobile application. So if you want to do it as a mobile application, or you want to convert your project in the form of a website, you can all do this with the help of the deployment engines. Then after deployment engines, it will help us to make sound decisions in optimizing the model. Now see, what is this all AI used for? It is helping us to drive correct data oriented decisions with appropriate decision making. After that, we can make conclusions and sound decision after optimization. Now optimization is enhancing the frequency, decrementing or decreasing the loss aspect, decreasing the error aspect. This is a small flowchart which will explain about the process which I've explained, the cycle of machine learning. That is data acquisition, then data pre-processing using NLP or CV. Since I'm dealing with text data, I have written NLP here. But if you are dealing with images, then image processing can be done. And for that, we have OpenCV. OpenCV is basically used for image manipulation, like image tilting. You can do image blurring, image coloring, optical character recognition. These are different aspects on which image processing can be done. Then followed by multi-class classification. Now, what is classification? Classifying a tweet. In this scenario, I have used a text or a tweet. So a text can be classified into either positive text, negative text, or a neutral text. These are the three classes of categories in which we can classify. So that is why it is called multi-class classification, because rather than having only two classes or binary like yes or no, rather than having like that, we have three classes here. So if you have two more than two classes, that is where multi-class classification comes into picture. Followed by sentiment analysis. Then here one important term is exploratory data analysis. EDA. EDA or exploratory data analysis also deals with understanding the statistics behind the data. How much is the width of the data? How long is the data? Or how many attributes or features there in the data? What are the important attributes? Then these all are done in exploratory data analysis stage. Then predictive analysis is usually done at the end, because here we are actually training the model with ML and DL algorithms. DL is deep learning. We are using deep learning models, and we are building a model using deep learning libraries. Deep learning algorithms are leveraged like neural networks. In case of image, you have heard about convolutional neural networks, or if you have not heard about it, it is basically a neural network which runs on image data, and the important characteristics over there is pooling, convolution. These all are the different techniques which are done on the images using CNNs or convolutional neural networks. So that is one example for neural network. Network is similar to the brain. It is a neural network having different layers in it, and the sole purpose of that is the algorithms help us to build a stable model, giving us high accuracy and helping us to predict or make decisions or even classify data properly. So in this case, it is opinion mining of the thoughts, emotion analysis. These all are the different even speech analysis can be done. Voice of a person based on pitch and tone. These are the different attributes we are taking or considering, parameters we are considering in order to analyze or perform the entire data analysis using artificial intelligence. So the final evaluation, after I come to the evaluation stage, this is a small snapshot of the sentiment analysis I have attached here. Over here, you can see this box is called the confusion matrix. Confusion matrix, basically, the final evaluation of the model is done using 4 metrics, which are F1 score, support, recall, accuracy, and precision. So accuracy is the most important here. As you can see, accuracy should be high of a model. We say that a model is accurate when it is giving us the correct expected output or the result. If a model is not, for example, just give an example of a flower classification model. When a flower is being classified, rose, if I give a model a rose flower, if the model or the machine learning model is correctly telling me that it is a rose itself, then it is a high accuracy. If it is, if the rose is not being predicted as rose, it is being classified as some other flower, like example daisy, that is where the accuracy lies, and accuracy is low because the model is not giving me the expected correct output. So always we should ensure the accuracy is high, and to do that there are n number of techniques which I'm really passionate, and if I was not time constrained, then I would have explained in detail about the different techniques which can be used to improve the accuracy of the model. Like there is a term like underfitting, overfitting, how to overcome that, and how we can leverage regularization. There are a number of techniques how we can use that in order to improve accuracy. So those are the different to dig further into deep learning. Those are the different aspects. So this is the confusion matrix I've shown here. See, I've just jotted down here: overfitting, regularization, hyperparameter tuning. These are the different techniques like fine tuning. These are done in order to improve the accuracy of the model, of the machine learning model, so that we get the correct output as expected. Then sentiment classification, to conclude, it is in fact as I told you, in images there is convolutional neural networks are used. In text for sentiment analysis, RNNs are used, and RNNs stand for recurrent neural network. And these days RNNs have been modified in the different advanced variants of RNNs like LSTM, that is long short term transformers, gated recurrent neural networks, GRUs, and extended RNNs. So these are just, I've mentioned the names, what are the different types of RNNs, and to delve further into different aspects, I would be happy. I'm giving the opportunity over here to explain in detail about the different neural networks. I'll be happy to do so. So these are the, as I told you, it's used in recommendation engine, opinion mining, and it is used in, also used in the chatbots these days, virtual assistants. So just giving you a small demo. This is a tweet emotion recognition. There is I'll just show you the Colab. I'll show you the runtime. If you want, I can run it right now as well. I have already run it. This is a tweet emotion data set I have collected, and first step is setup and imports, installing the Hugging Face NLP package. Hugging Face is a pre-built engine in natural language processing, which has a lot of pre-trained models as well as data sets. So this tweet emotion, that is understanding what is the emotion behind a tweet. For that, I have used a data set, and that data set has been collected from Hugging Face NLP package. I've imported all the libraries using this command, exclamation pip install NLP. See, collecting NLP, all the requirement has been satisfied. After that, I imported TensorFlow, NumPy, Matplotlib. Matplotlib is for use for data visualization, as I've told. TensorFlow, NumPy is used for the mathematical calculations, and TensorFlow is used for building the model. An alternative to TensorFlow is Keras. You can try that as well, and the most advanced is PyTorch. So after doing all this, I've imported the data, imported the tweet emotion data set, created train, validation, and test. So train, test, split, that is a word which is used here. I have the data, I have to 70% or 80% of the data should be fed to the model, machine learning model, as training data set. And the remaining 30% is to be used for testing purpose. That is to check if the model has been trained correctly or not. So that splitting is done using this train, test, split. Then extracting tweets and labels from the examples I have done here. Then to check what is the data about. Then the first label of the data of this is the tweets data I have collected from the Twitter API. You can collect it directly from Kaggle as well. See, data can be collected, as I've told you, from anywhere, be it JSON data, CSV data. This form of data I've collected is a CSV form, and that has been collected from Twitter using Twitter API. API stands for Application Programming Interface. So this is a label, and it's one example of a text like, I didn't feel humiliated. And what is this showing? I did not feel humiliated. Now we know that humiliated is a sad word. It is associated with sadness. It's not a positive word. So we can make out that it is coming under negative sentiment. Then the fourth task is tokenizing the tweets. That is splitting or chunking the tweets into small text into small tokens. Padding and truncating sequences. This is what padding is done here. Padding is done to remove all the missing data. Whatever data is there, we are imputing it or removing the missing data or replacing it with some other data. That is nothing but truncating sequences. Truncating is removing the redundant data or the irrelevant data, and padding is to make in uniform length. So if we do not have something uniform data, we can make a uniform data set using padding technique in neural networks. Then after that, preparing the labels, that is where we are creating classes to index and index to classes dictionaries. This is in the form of a dictionary. Here, see, in the tweets can be classified. Over here, I have, this is a multi-class classification example because it has more than two classes. The categories are sadness, joy, surprise, anger, love, and fear. There are 6 classes, and all the sentiments of that particular text you can see. Sadness is the most rated one because humiliated was the word. So this is anger, love, surprise. These are different intensities of the text. So we are assigning the text a polarity score. Basically, polar is nothing but the measure of whether it is a positive sentiment, how negative, how positive it is, intensity of that. And that finally, after training the model, we are creating the model. For creating the model, we are doing compiling the model, and here I have used the Keras library, tf.keras. I have used Keras and TensorFlow model, and the model is sequential model, which is a RNN, recurrent neural network here. And these in the different layers I have to do embedding. Now what is this embedding? Embedding is, see, we know that a machine learning model does not work on direct text. We need to convert or pre-process that text into numbers. Machines can only understand 0 and 1. So we are converting that text into numbers. We are assigning that text into vectors. Vectors, in maths, vectors are the mathematical containers, which is nothing but something like an array only. Vectors, it is used to store numerical representation of that text. So that is what we are doing. We are converting that text to a vector. So that is called as embedding. And after doing that, I have assigned the length, maximum length to it. Then it is a bidirectional neural network, and it is having dense layers, and the activation function I've used here is softmax. So the different activation functions, to name a few, like softmax, ReLU, tanh, and sigmoid activation function, which is used in logistic regression. So here I have used softmax activation function, and then I have compiled the model. For doing that, I have used Adam optimizer, which gave me the highest accuracy. See, I was talking about the matrix and how to increase the accuracy. If you run this model, you will understand that Adam optimizer is the best used. So different optimizers as well, like Adam, and there are different other optimizers. But what kind of optimizer will give you a less gradient descent, less loss function, and high accuracy is what you have to use. Then model summary. This is sequential. This is the model summary. Training the model, preparing the validation set and training the model. After model.fit is the command used here to train the model. I have run it on 20 epochs. Epochs are nothing but the training parameters I have used, like for how much time the model will keep training, how many iterations or how many cycles for the model is being trained on. That is epochs. Epochs, it is trained, and then evaluating the model. This is the history which is shown in the graph. And finally, the confusion matrix, which is going to give me the final exact measure of whether text is positive, negative, or neutral, or what is the hidden sentiment behind, hidden emotion behind that tweet. Is it sadness, joy, anger, surprise? That is given to me after evaluating. So after when I've evaluated and tested the model, you can see the sentence here says, I was feeling fairly keen. Now, I was feeling fairly keen, obviously, is a positive sentence. Now, what is a hidden positive? Is it joy or is it surprise? It is happiness. Of course, it is not that surprising also. I was feeling fairly keen. So keen is a positive word here. It is associated with emotion joy. So our model is given A predicted emotion, see the emotion actual which the model is being trained on is joy, and the predicted emotion is also joy. So the model is giving us the correct expected output here. That is a plus point. We have trained the model correctly, and then after training the model, this is the final confusion matrix, which is giving us the different intensities. The color will show us how extreme it is. So if it is in this blue color, it is less sentiment. If it is yellow, it is a higher sentiment, or extreme, it is high. So you can see here sadness, joy, these are different colors we are given here. So this is a confusion matrix which will finally help us in telling us what is how well our model is being evaluated. So that was all about it. This is during tweet emotion recognition. Thank you so much, and I hope I have given a small glimpse about what exactly is artificial intelligence, neural networks, and how exactly it can be leveraged